Amid the immense expanse of our galaxy, strewn with icy gas giants, desolate rocky planets, and vast stretches of silence, there lies one celestial body that defies expectations. Known as K2-18B, this exoplanet circles a cool red dwarf star over 110 light-years away in the Leo constellation. Despite its distance and alien nature, it has emerged as perhaps the most Earth-like world we've ever encountered, and potentially a cradle for life beyond our own. For years, astronomers have speculated that something unusual was unfolding on K2-18b. Initial findings suggested the presence of water vapor, followed by the detection of carbon-containing molecules. But now, thanks to the unparalleled capabilities of the James Webb Space Telescope, researchers are analyzing its atmosphere with extraordinary precision. The discoveries go beyond the realm of chemistry, pointing instead to signs that may indicate biological activity. The data has sent shockwaves through the scientific community. For the first time, clear biosignatures, gases that, on Earth, are produced only by living organisms, have been detected on an exoplanet. This is not conjecture. These are concrete measurements, and they may finally push humanity to confront a profound reality. We might not be alone. K2-18b is classified as a Hycean world, a hybrid between a hydrogen-rich atmosphere and an ocean-covered planet. It's significantly larger than Earth, with a radius 2.6 times greater and a mass 8.6 times higher. But what makes it truly extraordinary is its location, right at the edge of the habitable zone of its star, where conditions could allow liquid water to exist. This is not a lifeless, barren terrain like Mars, nor a searing gas behemoth like Jupiter. It's likely enveloped by a deep global ocean beneath a thick hydrogen atmosphere that moderates its temperature and shields it from harmful radiation. Observations from the James Webb Telescope have revealed that the atmosphere contains not only water vapor, but also traces of methane and carbon dioxide, both essential components for life as we know it. When these molecules are found together in a hydrogen-rich environment, they form a tantalizing picture, one where biological processes might be occurring beneath the waves. Then, in 2025, came a game-changing revelation. New data from Webb's Mid-Infrared Instrument, MIRI, detected a compound called dimethyl sulfide, DMS, which on Earth is produced almost exclusively by marine phytoplankton. Detecting DMS in an exoplanet's atmosphere is akin to finding oxygen on Mars, an unmistakable sign of life. Alongside this, scientists also found dimethyl disulfide, DMDS, a more complex molecule also associated with microbial activity in Earth's oceans. The simultaneous presence of these compounds in an environment rich in water and carbon-based gases has led experts like Cambridge astrophysicist Niku Madhusudan to suggest that K2-18b may be teeming with microscopic life. These aren't mere tabloid headlines. They are validated, peer-reviewed results supported by robust statistical analysis. The findings have led many in the scientific community to seriously entertain the possibility that we have discovered an alien biosphere, an oceanic world potentially, alive with microorganisms. If DMS truly stems from living organisms, the most plausible scenario is that K2-18b's oceans harbor phytoplankton-like microbes, tiny drifting life forms capable of photosynthesis using the dim red light from their host star. Some researchers even propose more complex possibilities: primitive filter feeders that sift organic material from nutrient-rich waters, or perhaps exotic analogs to flying fish, organisms that adapted to the planet's low gravity and dense atmosphere capable of brief excursions into the air. In many ways, K2-18b could mirror Earth as it was billions of years ago, when life first stirred in its oceans. Just as early Earth's microbial life gradually reshaped our atmosphere, similar processes might now be occurring on this distant world, and we may be witnessing it in real time. With these groundbreaking discoveries, a new debate has emerged. Should humanity attempt to contact this potential life, or should we remain silent observers? Some, like physicist Mark Buchanan, argue against transmitting signals, warning that such outreach might expose us to a civilization we're unprepared for, or worse, disturb a fragile alien ecosystem. Ethical thinkers like Dr. Anthony Milligan believe we have a moral responsibility to act with caution, prioritizing the preservation of any extraterrestrial life over our curiosity. On the other hand, astronomers like Avi Loeb contend that any intelligent civilization capable of receiving our messages would already know we exist and may not consider us significant enough to worry about. Regardless of where opinions fall, one fact remains: a message from Earth would take 120 years to reach K2-18B and another 120 years to return. For now, we wait, but the evidence continues to accumulate. The molecules are present, the ocean is likely real, and the idea that humanity is unique is rapidly losing ground. The spotlight, now firmly fixed on K2-18B, has prompted major space agencies and private aerospace companies to realign their priorities. While current propulsion technologies cannot carry us to this ocean world in under several centuries, plans are underway to escalate long-term observation. NASA is accelerating development of its LUVOIR and HABEX telescopes, designed specifically to detect signs of life by analyzing atmospheric chemistry. Meanwhile, the European Space Agency and China's CNSA are proposing their own advanced missions aimed at scanning distant exoplanets. The dream doesn't end with telescopes. Interest in interstellar travel is gaining momentum. The Breakthrough Starshot Initiative, a collaboration of scientists and investors, aims to launch microscopic probes propelled by lasers and solar sails at 20% the speed of light. If successful, these probes could reach K2-18B in 500 years. A long wait by human standards, but brief on the cosmic scale. While we may never walk its shores, we could someday receive a reply to a message we sent into the stars. The scientific ramifications of these discoveries are enormous, but their cultural impact may prove even greater. Around the world, religious leaders, philosophers, and thinkers are beginning to interpret this discovery through their own lenses. Some see it as evidence that life is a universal feature, not a cosmic fluke. Others view it with apprehension, fearing what it could mean for our understanding of humanity's place in the universe. Online discourse has exploded with hashtags like K2Alive and Ocean World trending across platforms. Documentaries are being filmed. Fictional adaptations are underway. Governments, meanwhile, maintain cautious optimism, releasing carefully worded statements that celebrate scientific progress without jumping to conclusions. But beneath the surface, something fundamental is shifting. The growing realization that we are not just explorers, we may be the observed as well. As momentum builds, new calls are being made to protect K2-18B and others like it. Not for our sake, but for theirs. International scientific bodies are proposing the creation of exobiological sanctuaries, worlds where potential life has been detected and must be studied exclusively from a distance. Astrobiologist Dr. Monica Vidari warns that if life on K2-18B evolved independently over billions of years, we have no ethical right to interfere. Some are even advocating for no-fly zones around such worlds, restricting the trajectories and emissions of future probes to prevent contamination. The underlying principle is simple: just because we can observe doesn't mean we should intrude. Perhaps the most profound lesson from K2-18B isn't about extraterrestrials, but about ourselves. In this distant, ocean-covered world, we may be witnessing a mirror of our own primordial Earth, a reminder of our origins. Studying it could unlock the secrets of how life arises, adapts, and flourishes, knowledge that may one day help us protect our own planet. For some, this marks a turning point where science, philosophy, and wonder converge to declare that life is not the anomaly. It is the expectation. K2-18B is no longer just a distant point on a star map. It has become a symbol of what lies beyond, a place that, against incredible odds, echoes the same chemical whispers as our own biosphere. For decades, we've asked, are we alone? But now, as the James Webb Space Telescope reveals unmistakable markers of habitability and perhaps life, that question has evolved. We're no longer just seeking belief. We're approaching confirmation. K2-18B may be the first. It may be the closest, but it will not be the last. Thousands of similar worlds await discovery, waiting for us to listen. And as we gaze across the void at this singular ocean giant, we're not only uncovering the universe, we're uncovering the essence of ourselves. So, do you believe life exists on K2-18B? Should we attempt contact or remain silent observers? If this truly is the moment we confirm we're not alone, what will humanity become next?